Hi guys, this is Aaron Rump. What we're going to be doing today is we're going to be programming a part on our Siemens control lathe. Okay, so what I have right here is I have a print, and on this print we're going to be covering several different methods on it. We're going to be covering the OD turning method, we're going to be covering the grooving method, and then of course I'm going to be covering the threading method. Okay, so as we go through this, I will be inputting these values into the machine where they need it. Okay, so the first thing I want to do is I want to create a folder. Now if I hit program right here, when I hit program, what it'll do is it'll take me to this screen. Alright, so from here I want to go to new. So what I can do is I can hit new. Okay, and I got a workpiece folder name. We're going to call it GoPro. Okay, now if I want to put a space in here, I can't put a space right there, and I can't hit the space because it's an invalid character. However, if I hold shift down and hit my underscore, it will allow me to make a space. So I want to put demo after it. I'll hit OK, and what will happen is if I'll hit cancel, and what I'll do is I'll look up here and I see that I have a GoPro folder, and I called it Dino. So if I want to, I can rename it, but I'm not worried about it right now. So what I'll go to is I'll go into it. Okay, so now with that folder highlighted, I want to hit new, and I'll type the same thing. I'll type in GoPro. I should be able to use my space now. It won't let me. That's fine. Let's hit backspace. GoPro. We'll hit my space underscore demo. Okay, I like it. So now what's happening is it's actually going to be opening up a program, and the first thing it wants me to do is it wants me to start identifying values. Now what you want to do is take your time right here. Okay, so what I'm going to do is I am using G54 on the lathes. More often than not, that's what you'll be using unless you're doing a flip-op. On describe, I'm going to go under no. If I wanted to describe it, I could describe it by simply hitting the select button to change my windows. You'll be seeing me doing that quite a bit. I am cutting a cylinder, and my cylinder is at 2 inches. However, if say my cylinder was 2.5, I would type in 2.5, 2 inches 500 thousandths, and hit enter. Okay, when I hit input, what it'll do is it will take me down to the next area by default. Now this controller will remember the majority of what you typed in the last time you're using this. So you'll see a lot of these variables that are already in the controller, but I will go over them. So my material is 2 inches. My Z0, the ZA, is the face of the part. Now if you take a look at this right here, you'll actually see in my image that I have a vice jaw right there. So on ZI, we'll call it I, it's actually saying how long my piece is that I'm cutting, my raw material. Okay, I've got 5 inches in there, and I'm actually going back 4 inches 600 thousandths. That's how far I should be sticking out. So if you have something on your paper or your program that says your stick out needs to be 4 inches 600 thousandths from the face of the jaws, that's where you do this. What we're doing is we're setting up our simulation page is what we're doing. Okay, so my overall material is 5 inches. Okay, 4.6 is how much I have clearance from the face of my material to the face of the jaws. Okay, so I like that. I've got a simple retraction mode. There are several different kinds. Okay, we're going to go with a simple retraction mode. What that means is before I come back to the face of my tool, or when I approach the face of my material, I'm going to have an additional 150 thousandths on it. Okay, in the X and Z. Okay, remember X is going to be down and Z is going to be coming over this way. Okay, I got 200 thousandths there, and they are an incremental. Okay, if I wanted to, I could change it to something else like absolute from Z plane, but I'm going to make them incremental. Okay, that's just how I'm setting it up. Now this right here is a pretty cool function, the tool change point. So what I can do is I can manually move my machine, or I can jog my machine to a location where I know it will not hit the spindle or the material when it rotates the turret to the next tool. So all I have to do is come up to this area right here. I can use work or machine. So I have handled to a clear point, and all I'm going to do is teach that position. Now if you notice, it took its current X and Z locations, and now every time it does a tool change, it will retract to those locations before orientating your turret. Okay, now for G code, this is a G50. This is the maximum RPM that my spindle can physically go while it's machining. Okay, so I've got 2,500 RPMs. That's not bad. I like it. If I start going with bigger materials, I'm going to start making that a lot smaller. Okay, obviously right here I have a safety distance. Now this safety distance is how far my tool will retract after every cut. Okay, I can have that at 1/1000ths, 1 inch, whatever it needs to be, but that's exactly how far it's going to come. Okay, so I feel like I have my header set up the way I want it. So what I'm going to do now is I need to start making my part. So the first thing I want to do on my part is I want to start making my contour. Okay, I'm going to make the actual part without the grooves and without the threads. Okay, so what I'm going to do is I'm going to leave it right here, and I'm going to come down here to contour turn. When I push contour turn, I have the ability to do grooving, plunging, stock removal. Now keep in mind, we'll be doing stock removal next, but I can't remove the stock unless my machine knows what the contour is. So I'm going to click new contour. Okay, I can name it whatever I want to. I'll call it contour. We'll call it contour 1. Okay, put a space in there. It won't let us do it. Contour 1, hit accept. Okay, so right now this is my starting location. I'm going to start at X0, which is the center of rotation, Z0, which is the face of my part, and I'm happy with that. So I'm going to hit accept. Okay, so from here you see these functions start popping up. Well, we're on a lathe, so you guys are just getting introduced to this. So we're going to use X and Z motions. So the first thing I want to do from X0, if you look at my simulation or my graphics right here, you'll actually see that I'm at the face of the part. So I want to move up. So I'm doing a 1/8 thread. So my first move is going to be a 1 inch. Absolutely from 0, I want to move out to a diameter of 1 inch. So I will hit enter. It is not on an angle. There's no taper. This is where I could put an ankle, a taper on there. And if you notice this has got a chamfer capability or a radius capability, which means when it comes up to that 1 inch diameter, I can put a radius or a chamfer or an undercut. So what I want to do is I want to put a chamfer on there. Okay, I'm going to put a 30,000ths chamfer, and I'm going to hit accept. Okay, and then I'm going to go to my next location. My next location is moving back in Z. If I look at my print shows me that I'm going back 1.5 from here to there. So that 1 inch diameter, 1.5 back. Okay, so from now on I'll just tell you what the print says, so I don't have to hold that in front of it. Okay, so let's move back in Z. We're going to go back a negative 1.5. Okay, I'm not putting a chamfer on it because it's going back, so I'm happy with that. So now I'm going to come back in X, and if you look right here, you can see that there is a little chamfer that it put on there once I made a move perpendicular to the previous one. Okay, so let's come back in here. We're going to type in our next diameter, which is 1 inch, 450 thousandths. Okay, everything's going to be the same. I'm going to put a chamfer on there. Okay, I'm going to put another 30,000 chamfer. I'm going to hit accept and accept. All right, I like that. So let's see. Now I'm going to go back in Z. Okay, I'm going to go back a minus 3 inches. So minus 3 inches. And then I'm going to come back. I don't need a chamfer, so I'll hit accept. And then I'm going to come back up, getting a bit repetitive, but keep in mind we want to do this right. 1 inch, 700 thousandths. And then I'll put a chamfer on there. Okay, this is what this will do, is that chamfer is going to create an edge, that chamfer, so it doesn't create an edge, that'll be very sharp and might cut you. Okay, so we're looking really good. So now I'm going to go back a negative 3.5, 3.5 inches. I like it. Now we're going to come back again. Okay, we're going to go up, I'm sorry, 1 inch, 950. Okay, and I don't want to put a chamfer on that. Well, I can if I want to. We're not going to put one on this one just because you don't have to put one on all of them. Okay, so I'll hit accept, and you can see right here that I don't have a chamfer on there, but now I got to take it back the total length, which is 4 minus 4 inches, 300 thousandths, accept. So here's the cool thing. I have my entire part programmed. And if you look right here, you can see 1 inch, 2 inch, 3 inch, 4 inches. It's a little bit past 4 inches, and if you see me coming down, this is my 2 inch marker. You can see that I'm just a little bit below the 2 inch. So I'm going to hit accept. I have my contour. Okay, so remember I told you to keep that stock removal in mind. Let's hit stock removal. Okay, so now's where we're going to come through here, and we're going to actually define the turning cycle. Okay, we got the contour, now we're going to define the turning cycle. We're going to do a complete. Okay, so I'm going to arrow down. So I've already built my tools in the turret, and I have another video where I'll show you how to build the tools. So what I want to do is I want to select the tool, and I want to come down and find what tool. So this is a DNMG. We're going to call it an OD tool, a turning tool. Once I arrow over it, I hit OK. Now if you'll notice, if it wasn't already there, it will be now. Okay, my D value, edge number, using the right edge. Now my revolutions per minute. Okay, that means that I'm going to be going pretty fast. Okay, inches per revolution, I'm sorry. So that means 1 revolution, it's going to advance 15 thousandths. So roughing, I want to use 12 to 15 thousandths. For finishing, I'll use 6 thousandths. Okay, so let's change it to 12.012, hit input, and now I have G96, which is constant cutting speed, okay, constant surface speed, or I can set a constant speed, okay, of 600 RPM, okay. So what I want to do is I do want to use a constant surface speed, okay. So 600, not going to be bad. If I was cutting steel, I might go down to 200, 250. So cutting aluminum, I'm going to leave it at 600. I like that. So I hit it, input. Now if you look at these triangles, okay, look at the graphics. That is exactly what it's going to do. It's going to try and take off all the material all at once. I do not want to do that. So what I'm going to do is I'm going to hit select, and I have roughing with finishing. I also have roughing, and then of course what was on the screen a second ago, which is just finishing. So we're going to go with roughing. Okay, so this is what we want. I will hit accept. Now I have these cool functions here. I have longitudinal, okay, longitudinal, and then I have a face, okay, which is very cool. That's exactly what will happen when it's cutting it off like that. I also have a really interesting one called contour paralleling. Okay, so what happens here is that's exactly the tool path that you're going to see. Well, I don't want to go with that. I want to go with this one right here. I want to do outside. If I wanted to do boring, I could just switch over by boring by hitting my select button. So I'm doing outside. If you notice here, I have a maximum in feed, which is just my depth of cut. 50 thousandths sounds good. Let's make it 40 thousandths just so you can see it change. I hit input. Now right here is how much I want to leave on the diameter, okay, for a finish pass. So I want to leave 10 thousandths, which means if I'm cutting that first diameter to 1 inch, when this tool gets done, it will measure 1 inch 10 thousandths, okay? So I like leaving 10 thousandths. For Z, let's leave 5 thousandths. So I'm going to put 5 thousandths, hit accept, and then down here, oh, we'll go back to where we were, I'm sorry. So down here, I have other variables that I can change, but I'm not going to change these to anything at the moment, okay? So that's why I accidentally hit accept. So let's hit accept. So now I have my contour, and if you notice, I have a little line that is merging the contour to a stock removal, okay, because now those two are connected. So now what I want to do is I want to go to stock removal again, and this is where it gets really easy. I will keep the same tool in there. If I wanted to, I could change that tool to whatever I wanted. I'm going to slow down my inches per revolution. I can increase my surface footage per minute, and here's the one where I want to change it. I don't want to take a bunch of passes. I want to take one pass. So therefore, that is my finishing operation. Once I change that, I hit accept. Okay? One thing I want you all to do when you're making these programs is once you get done with a feature, you need to come down here where it says simulation. We want to simulate it, because when we do that, my machine will actually look, find, and catch errors. Okay? So as you can see, I have my material in there. It took it off pretty fast. Let's do that again. Let's go back, program controls. I had my feed rate a little bit high. Okay, so we'll hit simulation off, and then we'll hit simulation again. This time it'll go a little bit slower. And if you'll notice, when this comes on, there's a yellow profile inside the blue stock. That's the actual profile that I'm making. So as you can see, I'm taking off small depths of cuts all the way down to the yellow line. Well, when it gets done, you're going to see it take a finish pass where that yellow line will disappear. That is my finish pass. Okay, so that's good. That means I have the majority of my part done already. All right, so what we'll do is we'll go back to edit mode, or I could hit back, or I could turn simulation off. I'm going to hit edit. Okay, so now I want to make the next thing on my print. So I have two grooves. Okay, I have a groove that is after the threads, and I have a groove that is after this diameter right here. Okay, so if you'll notice, both of these grooves are 200 thousandths wide. Okay, so what it's going to ask me to do is it's going to ask me for the diameter before the groove, and it's going to ask me what the groove finish diameter is. So what we'll do is we'll go into turning, not contour turning, but turning. On here I have stock removal, groove, undercut, thread, cutoff. So let's go to groove. And if you notice here, it says select tool. So I will select tool. I will come down to my groover, okay, and I will hit OK. So I do have my groover there. Okay, my inches per revolution is at 5. Let's not go any higher than that. Let's keep it at, let's change it to 4 so you guys can see it change. Now I got a constant surface speed. Notice how I changed it just a little bit because I don't want my part flying out on me. Or I can change it, like I said, to a constant RPM. Now when I type a variable in here, say I type in 400, and then I come up here and I hit RPM, I can change it right back to the same RPM. It does not translate over. Okay, so that way if you want to keep it at that same RPM, you won't be affecting it unless you physically change it. Okay, so I am doing a roughing. I'm not doing a finishing. A finishing would just come right in there. Okay, I'm going to do a roughing and a finishing, or I can just do my roughing, and then right here on this UX and UZ where I leave excess material, I'm just not going to do that. Okay, so I got my roughing selected. Now right here you want to pay attention because I have the position of the machine. Okay, this is where the machine's at, how it looks. So obviously I'm getting some errors in here as I rotate it. So I want to keep it there because that's the type of groove I'm going for. If I arrow over, notice where this blue circle is. Okay, that is the left side of my insert, and it is the tip of my insert. Okay, if I move it around, it will move from here to there to there. Okay, so I have it in the correct location right now. What you're seeing in the simulation is what the part program is actually going to do. Okay, so if I want to program from here, it'll have an interference with my tool. Okay, see how I'm getting my interference right there? So I'm going to program from right there because I touched off on the left side of my tool. So what I'll do is I like that, so I'll go down. So my starting X position, okay, because I've turned my part down to 1 inch, is at 1 inch, okay? That's where it's gonna go to when it approaches it in X. So I don't wanna go right to 1 inch, so I'm gonna put 1.2, okay? So I should be 200 thousandths above the part. In all reality, it'll probably be 1 inch 300 thousandths because that safety clearance that we put on that very first one, okay? But I'll put 1.2, and then the starting location, how far back it goes, is 1.5. It is a minus 1.5. Now, let me show you on the print that that is the shoulder location, 1 inch 500 thousandths. That's what I'm gonna put in there. When I put in the width, that's where it'll start compensating for the width, okay? So I am at a minus 1 inch 500 thousandths. The width of my groove is 200 thousandths, so 0.2. Okay, now this is the groove depth. Now, don't get lost on here. It is what the finished diameter is going to measure when you're done. So in this case, my print is telling me it is 750 thousandths, okay? And then I have a maximum in feed. I'll leave that at 50 thousandths, okay? Now right below it, I have how much I want to leave for finishing passes. Well, I'm just grooving, so I'm not worried about it because I have the tolerance. And I have my finish allowance in Z, so I'm good to go. And now if I wanted number of grooves, I could tell it how many I wanted, and then it'll give me some more options to tell me how far away I want it to be. So I'm happy with what I have. I'll hit accept. I just made a feature, so I need to simulate it. If this simulation comes out good, we'll continue on with the next groove, and then we'll finish with the threading. So as you look in there, you can actually see I have the profile, which is in yellow, and I also have that groove. Now you'll notice the way this is programmed set up that that grooving tool will come up to the shoulder of the part. If you do not want it to do that, we can increase that variable to where it is more, and I'll show you that on the next part. Okay, so it does come right up to the shoulder, so you need to make sure you have your tool set right. But what it'll do by us being close to it is it will eliminate airtime, okay? So I like that right there. Let's go back to edit. Let's make us another groove. So we'll go to turning, groove. We want to use the grooving tool. We like that. It's already set up for us. We are doing a roughing. Our tool and locations are set up. Now my X diameter is 1.7 that I'm going up next to. So I'm going to change that to 1.75, give me 50 thousandths, okay? Now the location of it is a minus 3 inches. It is still 250 wide, and the finished diameter is 1 inch 250 thousandths, okay? Everything else is the same. I'll hit accept. That was really fast because it remembers everything. So I made a new feature, and now I'm going to simulate it. Now pay attention to this yellow lines for the grooving. So if you look there, my grooving tool is a little bit further in on the shoulder, whereas this one is out past that diameter, so the side of my tool will not run into the face of that shoulder, okay? Now keep in mind, it will cut air for a minute or two. That's not a problem, okay? I say a minute or two, I'm exaggerating. It'll just take maybe about another 10 seconds, okay? So you can tell I got my grooving, okay? Then it comes over, same thing. It's going to do some roughing, 50 thousandths at a time. And then it goes ahead and it finishes it, okay? So now that I have my grooving done and my turning done, it's time for some threading. So let's go back to edit. Let's go back to turning, right? And I have my thread option right here. It's time to finish this part, okay? Now I've got complete input screen, okay? Now I've got simple, okay, where I can type in a different way, but we're gonna use the complete so we can define everything, okay? So what I'm gonna do is I'm gonna come down and select tool, go to my threading tool, okay? Then I got this right here. Now I can change this to different styles of tools, right? Or I can hit the number 1 and it will drop down that window so I can actually come over here and pick. So I am using a UNC thread. So I'm going to hit select, or I'm sorry, I'm going to hit input. Now when I do that, by default, because we had already programmed this, I have my 1" 8. Now if I don't want a 1" 8, I can hit the 1, and I can come up here and I can select whatever thread I want. Okay, now see the thread height right here. If I select something different, my thread height changed, okay, because it's already calculating what its parameters have set. So let's go back up here. Let's hit our number 1. We're doing a 1" 8. Okay, I will hit input. All right, now notice on my spindle speed, I don't want to use constant surface speed because I don't want my RPMs and my spindle revving up and slowing down, revving up and slowing down, revving up and slowing down. I don't want to do that. So what I want to do is I want to make it to where it stays at 1 constant RPM. Okay, so that's what I'm going to leave it at. Now I have a roughing and finishing because I don't want 2 separate tools doing my threading. So I'm going to leave it at a roughing and finishing. I'm doing a linear. Now there's several different ways I can do this. I can do a digressive or I can do a linear. I'm going to leave it on linear. I have external or internal. We are doing external threads. I'll leave it there. Now you're going to have to look at your machinery's handbook and see what the diameter needs to be at its maximum condition for cutting a 1" 8 thread. So I'm going to give you a hint. 990 thousandths is right there in the middle. So I'm actually going to type in 990 thousandths. Now the reason why is, see this 76 thousandths down here? It's only going to drop 76 thousandths from 990 thousandths. So if I told it was 1 inch, right, it would only drop 76 thousandths. Well, there's still that 5 thousandths left where I put the OD of that tool. Okay, and I can change things if I need to. So let's put this at 0.995. Input. Z0 is the face of my part. Now notice my print said I need to go back 1 inch 300 thousandths. Well, I need to go back at least 50 more thousandths so that I complete my thread all the way into the groove. Okay, so that's why I have the 50 thousandths in there. Okay, I have my thread advanced. Okay, it already knows the pitch. So 1 divided by 8, or I'm sorry, 8, yeah, that's right, 1 divided by 8 will give me my pitch. So it knows what that's going to be. Okay, so next thing I'm going to do is I'm going to come over here. I'm going to find my thread height. We'll leave it alone right there. And then I've got in-feed slope. I can change that angle, but I don't want to. So pretty much everything I'm going to leave is right here. Now here's my depth of cut. Now I don't want to put this at 76 thousandths because then it's going to take the entire depth of cut in one pass. You're gonna hurt your machine. Okay, so what I want to do is I'm going to put this back at about 5 thousandths. Okay, so that makes it a lot smaller. That is my depth of cut for the in-feed. Okay, we're not going to change anything there for finishing allowance. However, if you've ever threaded, you've heard of something called a spring pass. Now what I want to do is once I am at depth, I'm going to leave that at 2 because what it'll do is it'll finish the thread and then it will take 2 passes to try and get rid of any push off or spring that's in the part. Okay, and then of course we have our return distance off of there. Multiple, if I wanted to make 3 or 4 entrances into the thread, that's where I would do that at right there. All right, so here's where I'm at. So now let's simulate it and see where I'm at. So I've got my simulation. It's going to start with the turning. What I'm going to do is I'm just going to speed it up just a little bit. Okay, so that way we can see that it's doing its turning. Okay, then it's going to do its finish pass. Okay, there's its finish pass. Then it's going to come up, it's going to do its grooving. Okay, now it's doing the threading. Okay, so the threading does take a little bit, but you can actually see my threading tool going, and it's going to keep going until it gets to that line right there. So I'm going to speed it up real fast, and then it's going to finish the part. Okay, so it did finish it. So right now, if I wanted to, I can move my part over here, and I can zoom in, okay, I can zoom in on my part and see my threads, my chamfers. I can see whatever I want on this part, okay? Zoom out a little bit. And then when I'm done, I can hit auto zoom to go back to a full screen. Okay, so notice I did something on my threading. Let's look at our threading by simply hitting the side arrow with the threading highlighted. Now I told you that I put this at 995 thousandths. Now when I made my contour, it was not at 995 thousandths. So I need to go back and fix my contour, okay? So what I'll do is, if you look over here, I can actually move up and it'll highlight on the screen what I am motioning to. So right here, okay, I said 1 inch. Well, that's not right. It needs to be 0.995 input accept, okay? So just like that, I can go back to the very beginning of my part and I can go back into simulation and run everything. So if I need to make minor detail edits, I can do it just like that. Now this will probably run pretty fast because we had sped it up. Okay, if not, we'll go ahead and speed it up a little bit. Program control. We want to get this finished because we know it all looks pretty good. We don't have to watch it. I suggest you guys go ahead and watch it when it's running. Let it do its thing. We're going to get all the way through this bad boy. All right. It's almost done threading, so we're done. So right now we have gone through and we have done our turning. We have done our grooving and we have done our threading. And my program is only 1, 2, 3, 4, 5, 6, 7, 8 lines long, okay? And what it'll do is it'll do the whole program. So on my next video, I'll actually have my GoPro in the machine. That way we can watch this program run. So if I want to go back to my programs, I simply hit program, and this program is here until I delete it. So like I said, my name is Aaron Runk. Thank you for watching, and I hope you enjoyed.